continuing with the V model of testing, this presentation talks about the second step, the integration testing. So as mentioned on the earlier presentation, the unit testing is the one coupled with programming, and the integration testing is the one coupled with the design. The reason why integration testing is coupled with the design phase is because the integration testing focuses heavily on ensuring that the different components and parts work together seamlessly and that the interfaces between the modules work as intended. So, if we consider the software product sort of like a combustion engine, the good practice on object design would be that the parts are interchangeable. For example, if we need to create new network interface or create a better search algorithm, it should be enough to just replace that component. If that component has clearly defined interface and everything works as intended, then it should be enough to just replace the part and ensure that everything still works. The integration testing is focused on ensuring that these interfaces between modules and all the other things work still seamlessly and that all the interplay between the modules works as was designed. Henceforth, the integration testing is joined or coupled with the design phase. So, in short, integration testing ensures that the components work together as intended. The idea is that the components are introduced one at a time. We know that the previously integrated parts work together, and we can add one new component at a time, because if there's a problem, there's a pretty good idea where the problem originates, or at least we can know that the problem arises because this new module uses the services or something else happens. So instead of having the entire system full of possible points of failure, we all know that the problem originates or is caused by the new module. And there's a couple of new strategies how to make this work. I'll get back to that in a couple of minutes, but to keep in mind that if you have taken already object-oriented programming course, you probably have heard the terms cohesion, coupling and encapsulation. The cohesion means that the component is able to do all the necessary tasks by itself, so it's sort of a self-supporting or independent part. The coupling means that how much the component requires other components around it, or is it dependent on something else, and encapsulation in general means that functionality is encapsulated within one logical component. Meaning that in the integration testing it is crucial to have high cohesion, low coupling and use the idea of encapsulation in general. And of course this also means that the principles of object-oriented design are actually correct and you should do that. This is just as a side note, because this is the cohesion and coupling are a couple of things that usually generate errors which are found during the integration testing work. So, if we have the system being built here, the integration testing more or less tests one component around with the all other components as a comparison to unit testing where we just do internal testing in one place. If we have already something existing components, for example like the framework component here, we can use the existing parts, add our own part, and for the other relevant components which are sharing information with the tested part, we have to use driver studs or test studs or any other way to simulate or emulate the behavior if we want to do the integration of this one part. So, I mentioned earlier that there's a couple of strategies on how the integration works. Well, the first one is the Big Bang integration. It has nothing to do with the TV show sharing the same name, but the name Big Bang actually tells us how everything happens. So we take into the consideration that every component exists. These are The boxes are here representing the component and the lines representing the dependencies or connections between the different components. So, if everything is unit tested and all the components exist, the integration testing can be as simple as just putting everything together and seeing if everything works. This is also known as smoke testing, since usually the first Big Bang integration ends up with a smoke coming out from some part of the product. Hopefully it's metaphorical smoke, not physical smoke. But anyway, this sort of integration isn't really integration because everything is integrated at once. But this establishes, for example, the baseline on can we start the system's testing work already. So, but if we are doing the actual integration, there's the top-down and bottom-up. The top-down approach, as illustrated here, starts with the upmost part of the system, the user interface or any other part which receives input and shows output or does some activities. We start introducing components one by one into the system, going towards the more technical and actually working parts. This would mean that if we were controlling something like a crane, we would start by taking the command console and adding new features and functionalities and going towards actually driving the crane with the command console. Of course, the problem here is that we only have parts which are already integrated here and we have no actual functionality. Also, since we want to test the parts on the upper part of the system, we have to create a stud or driver or simulation for all the parts below what we are currently integrating. Also, other part is that do we want to do the integration in layers, or do we want to add one full feature at a time, so we go one branch to the end and then another and then another and then another. This would give us more functional prototype. But on the other hand, if we are just creating the user interface first, integrating everything into it, and then adding the more functional parts of the system, we are able to start, for example, the user interface testing in timely manner. Anyway, the top-down has, of course, the flip side of the coin, being the bottom-up. This is basically the other way around. We start from the most technical component and start seeing, for example, that the database connections and calculations and algorithms and the hardware connections and sensor reading modules or libraries are functioning, then combine them into more functional parts, finally coming up with a functional system when everything is working together. Of course, here the problem is the other way around. We don't have functioning user interface, so we have to use simulated parts for that part. But on the other hand, since we start by some clusters which we start to merge at some point, we also can divide the testing work more easily, because we can, for example, say that this part here is testing the functionalities of the analysis system and this one is testing the functionalities of the data collection system. So we can do that independently with two teams, and when they both are working, we just merge the projects into the upper parts of the testing work. In any case, no matter what the approach is, there's also, for example, the sandwich approach, which is more or less the top-down and bottom-up at the same time. We have three teams, one starting with the user interface, for example, in this case, three teams, one starting with the user interface, others starting with the technical parts, and they are going towards each other. In any case, no matter what the strategy for integration is, it always means nothing more than the work done to ensure that the components work together as intended. So, keep your components in high cohesion and low coupling, and encapsulate all the functionalities into logical parts or something that can be replaced, like components from a combustion engine, then you are good to go and your integration testing should go through nicely.